Did you know that vulnerability exploitation accounted for roughly 15% of all breaches per Verizon's 2024 data breach report? Now, that may not seem like a wildly high number, but it's important to note that's up over 180% over the previous year, which is kind of crazy. That further underscores the importance of keeping your software up to date. And now, while aiquery is not inherently a vulnerability scanner or anything of that nature, it can be massively helpful in ensuring that your environment is indeed up to date by performing low resource spot checks between your scheduled vulnerability scans. So let's say you see a new CV come out, patch Tuesday, what have you, and you want to check across your environment to gauge exposure. Boom, aiquery's got you. Identify it, rectify accordingly, and move on with your life. So without further ado, let's hop right into the tech and show you how it's done. All right, so we're going to start off with a very simple use case, but stay tuned to the end of the video because we're going to kick it up a notch, Emerald Ghazi, for all of you old like me. And we're going to get in some really cool stuff. So the simple use case to start it off here is Python. Let's say we see a vulnerability, the news, the MVD, saying that there's a vulnerability for Python 3.11.4 as the version. So I could always ask AI to create this, but I actually can write this query. It's very simple, not complex. So here we can see we have our whole environment, all massive 2 machines in my huge test environment selected. They are both Windows devices. And so in that case, we'll use the programs table, which is going to look for installed applications on Windows. And we want to gather the name and the version. So simple enough. We'll do select name, comma, version from programs. If I could spell that, help, programs, where name like, and then we're going to do wildcard Python wildcard just to be safe, and version like, and then we'll do 3.11.4, and then we'll do a wildcard just in case, because so technically it's the patch version, but they may have hot fixes so they can append things beyond the 4. So here we have it. Again, very simple. We'll hit execute and we'll check out results, and then we'll refresh and we see we have 1 out of 2, and then we got both results right here. So that's perfect. We can see the only device specified here is the desktop device, even though we have results from both, which means that we can logically interpret this as saying, hey, well, we have the results back. This version does not exist on the EC2 instance, this one, but we do have results of multiple instances within our desktop device for this specific version of Python, which has the vulnerability. So boom, there you have it. You can quickly take a news article, reference, what have you, and spot check that specific versioning across your environment. 2 seconds, good to go. And let's go ahead and update or rectify the situation accordingly. So great video, guys. Thanks. Yes, everyone. All right, let's move on. No, obviously it's not the end of the video. So let's take it one step further. That is a real use case, quick spot check, but let's take an actual real life example, because a lot of times when you're having these actual vulnerabilities, it may not be in one specific version, but a range of actual patch fixes or within the version. So let's look at the National Vulnerability Database, and then right here we can actually see an issue is discovered in Python version 3.11 through, which is technically 3.11.0, right, through version 3.11.4. We can also see down here that it doesn't actually happen in versions 3.10 or earlier, because it's only the newest ones. And the last piece of information is it's a relatively high score of 7.5, so we want to check this across our environment. Now, how exactly would we do that? Well, the obvious answer, Nick, would be, why don't we just go ahead and move over the wildcard so that it's not a 4. So yeah, let's do that. Okay, me, it's not going to work. I don't know why I'm being so condescending. But then we'll do 3.4.wildcard, and we'll show you exactly why it won't work. So see results, and it will return results like we expect. And here we can see we have 22 rows, which is awesome. And what we can also see is that, hey, we have the second device, the EC2 instance in here. So we have all the data we saw in the first query, right, the 3.11.4. But what we're also seeing here is a 3.11.1, right? So an even older version of Python, but still within that range of 3.11. On this device. So hey, good to go, right? Well, then you have this guy right here, 3.11.8. So the problem is that we're searching everything that's 3.11 star. We actually want to search the range of 3.11.0 to 3.11.4. So how exactly are we going to do that? Well, one of the major downsides and one of the reasons that OS query can be difficult for actual vulnerability assessment is in the nature of the tables themselves. So if we look at this, we see programs and we see version, right? And we see the type of version is text, so it's a string. So we can't do equivalency statements, greater than, less than on a string, because it just is a string. It's not an integer that you can do greater than or less than. So then, hey, why didn't it just be an int from the get-go? Why are they trying to make it difficult? And this is a fun one that I realized many years ago when really diving into actual products and tech, version 3.11, right, is newer than version 3.2, obviously, right? But as an int, it's less than 3.2 because of math. 3.2 is more than 3.11. So that's why it's a string, which is kind of funny, kind of comical, but does make this slightly more difficult. Don't worry, that's where AI query comes in, and that's where we can resolve it. So what we actually want to do is take this query. So we'll go ahead, we'll do edit and rerun query, and then we're going to hit refine. And then what we'll want to do here is we'll say cast each item between the decimals as an int to represent the major, minor, and patch fix versions. Ensure format is correct. Probably don't need that last part, but yeah, whatever. So then we'll do version 3.0 to 4 with cast as int. Let's check it out, and here we have it. Again, nothing too crazy. So we can go ahead, we could accept this, and then we could execute it. But actually, no, we're going to do that because what you can do is you can then filter now that these are integers. And what's nice is that if we converted the whole thing to an integer, right, then we run into the 3.11 versus 3.2 situation. But since we're doing each individual element as an integer, 11 is greater than 2. So we can actually do comparisons between them, which is awesome, whether it's within our filtering, which we'll show in a minute, or whether it's within our query generation. So let's execute this. I'm actually going to copy this title just so I don't have to type it again in fat finger. So we'll copy that back out and cast this int with comp. And so then what we'll say is we'll say only return results where the major version is 3, the minor version is 11, because again, remember anything below that, it doesn't have this problem, and the patch version is less than 5,000. And that's because we actually want it to be 4 or less, but since they have the hotfix numbers, we can't do less than or equal to 4, so we want to go up to 5 and say anything less than that. And so we'll hit refine, and then let's select our 2 devices in our massive environment that we're searching across here again. And yeah, should get a result here from QuerySmith and refine momentarily. Boom, and there we have it. Program version, cast in string as integer, less than, boom. All right, and we can see we have the one that we ran first right here, and then we can actually see that we have the other one with the comparison built in. So first let's show, if you didn't want to do the comparison within the query, totally fine. As we can see here, we have each of these broken out into sections of major version, minor version, and patch version. Since those two are the same here, we're only going to want to focus on patch version, but this holds true, again, if you're trying to compare across different versions that aren't just the same major and minor version. Now these are workable integers. And here we can see that we have the version 800 and change, or 8,000 and change, and then the ones that we already know about. So what we can do is we can use filtering. So please ignore my face because you can still kind of see the filter. So I apologize, but I'm not good enough at video editing to move my face around. So dynamic filtering. So again, obviously better for a large scale environment, not my little tiny test environment and test lab here. But what we can do is we can go ahead, and if we wanted to, we can actually add in logic for each of these. So we can say major version equals 3. These work as implicit AND operators. Minor version 11. And then we'll add one more, and we'll do patch version. And we'll say patch version less than and equals. And then we'll do the highest one we have here. Or let's just do 5,000 and hit apply filter. So boom, there we have it. Doesn't look like a lot, but it went from 22 rows to 21 rows because we filtered out that one outlier, which if we wanted to actually show that, we can show greater than or equals and hit apply, and then this is the one that we filtered out. So you can do it after the fact if you prefer the filtering, or if you prefer the AI query generation side, you can do it proactively, which is what we have here. And as you can see, 21 rows because we used the logic right within there, right within the query, and did the comparison for us. So here we have it. Here's what we have that is all potentially vulnerable within our environment, given this specific NVD vulnerability that we discussed. And yeah, we've gotten there. That's how we actually got down to each of the results. So hopefully that was helpful. Again, just to recap, we took a quick spot check use case, which you can just do very simply and say, hey, does this version exist across our environment? Can be helpful for sure for quick spot checks. But We've then used AI to take it one step further by actually casting these integers as, or these strings as integers, to make them more workable so that we can actually add in ranges and different caveats and filter the results as though they were integers, even if they were initially being pulled in strings. And that's where AI becomes wildly helpful, because I don't know about you, but I wouldn't be able to write this query. But as you saw, AI was able to do it in a matter of seconds. So hopefully that was helpful, and hopefully you learned a little bit about how AI query can help out within spot checks and vulnerabilities within your environment. Check out our YouTube and our LinkedIn for additional videos. And until next time, thanks everyone. Bye.